All right, let me show this by example so that you also just understand that this is actually true. Let's say the message is number 89, or it could be 8 and 9, but we use 89. As I said before, we use different numbers for the letters, but let's set that aside for now. I want to send a message which is 89. The encryption then that we do, that I said, is we take the number m and we take it to the power e, and then take modulate the number n that we also give people. So in this particular case, the cipher number of 89 will be 1394. So now how do we decrypt this? Well, what we do is we take the cipher, as I said, right, and we take it to the power x, and you know what your x is, your private key, and take the modulo of n, right, divide it by n and take the remainder. So as you can see, and you can compute this yourself, so the cipher was 1394. We take this to the power 2011, this is our x, and we divide it then by 3027 and take the remainder, and the remainder is exactly 89. So in other words, as you can see computationally here, this actually works out. Now, you can also use this public-private key for the signatures. The principle is the same, right? So basically what we do is we encode. What you in this case though do is that the recipient has only the public key, and you as the person who's signing has the private key. So what we do here, we have again the same n, the same q, the same message. We pick the same e and we pick the same x number. And so now the public key that you have is the number e again that you send, and the private key is your number x. Okay, so what you do is, in order to sign the message, is you take the message, you take it to the power of your private key, and then compute this, divide by the modulo. So the number n that you have, right, which is 3027. So the result of that is the number 545, as in the remainder of this computation is 545. So this is your signature that you send. Now somebody who receives the signature has to check whether the signature checks out. So what do? They take the signature, they take it to the power of the e number, the public key that you give them, which is 3, and then divide it by 327 and look for the remainder. And what they see is that number divided by the remainder gives you 89, which was your original message. So in other words, the signature that you've applied to this message checks out in the sense of that it is you indeed who has the right private key has actually signed that message. And in none of these operations you have ever revealed what the private key is. So this is how this whole thing is correct, and how you can prove that you are the signer without actually showing your signature in any form.